Well, the ECTRIMS conference has come and gone for another year. They talked a lot about remyelination. Does that mean I'm done talking about remyelination? Well, maybe, but maybe not. Hello, and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam. I've been living with multiple sclerosis for almost 40 years. On September 20th, we were given the opportunity to tune in for free to the Patient Community Day that was part of ECTRIMS. We could watch the streaming, and then a few days later, they uploaded a recording so we could watch it at our leisure. And this was the panel that discussed the conference as a whole. It did not in any way summarize everything that came out of the ECTRIMS conference. I think you kind of have had to have been there for that. And articles are being published even now that talk about things that came out in ECTRIMS that I didn't hear about at Patient Community Day. It still did cover the highlights pretty well. And the first section really was on remyelination, because that's the subject that everyone's thinking about right now. Everyone's talking about it. And I'm pretty excited that everyone's talking about it, because if there were no realistic hope that we could see remyelination therapy happen in our lifetime, they probably wouldn't even be talking this much about it. The research that's going on is probably costing hundreds of thousands of dollars, if not more. The pharmaceutical companies, they're not in a charitable line of work, so they're not just doing this out of the goodness of their hearts. They're doing it because they see that money is to be made. And whoever gets to be first to the starting line with a therapy that's approved by the FDA for remyelination in multiple sclerosis, they're going to be making some pretty good money. So it's a good return on investment. That's how they look at it. And, far be it from me to begrudge the pharmaceutical companies making a little money if it really truly benefits us. But be that as it may, now that the Community Day recording has been uploaded and made freely available, I can go ahead and play a portion of it that covers what the panel thinks about remyelination and the outlook for that. So let's check it out.
My name is Brett Drummond. If the accent hasn't given away, I'm joining you from very far away from Melbourne, Australia. So let me introduce to you our panel of people who we have here today. And I want to say to start with that all of these individuals accepted this so excitingly, and these were all of our people who we first chose. And when you look at the lineup of amazing individuals who have done this, I think this really emphasises the commitment that ECTRIMS and all of the MS community have to this event. So starting from my left here, we have Tim Coetzee, who's CEO of the National MS Society. Next to me here is Marlene Kappenkruger, a patent attorney, and wonderfully a person living with MS, joining us on the panel as well. Melinda Magyari, Director of the Danish MS Registry. Have Bruno Stankoff, who you've already met from Sorbonne University. Martin Torre, current President of ECTRIMS, joining us from SEMCAT in Spain. And last but definitely not least, Mitzi Joy Williams, neurologist from the Joy Life Wellness MS Centre in the USA. So an amazing panel of people to share their insights with you today. Our first topic, even though the title hasn't come up on our slide here, I can tell you that I know which one this is remyelination. So just to put it into context before we throw across to our panel here, while we have a number of existing treatments that can now stop new damage from occurring or slow new damage from occurring, none of our current therapies are able to repair that damage once it exists. This is why remyelination or myelin repair is so important. It is really seen as the next major advancement in the treatment of MS, because we have a hope that with an effective remyelination therapy, we can start to restore function. So with that, I'd like to throw to Tim to give your thoughts on remyelination in general and what we've heard about it at ECTRIMS 2024.
Well, I think, first of all, it's great to be with all of you. As Brett said, remyelination and myelin repair is truly the next frontier. And one of the things that has excited me about the conference is that it's not something that's so far off. we have known that the body can repair itself and that the brain can repair itself. I wasn't here 20 years ago for the ECTRIMS, but back then I think myelin repair was seen as so far off as almost impossible, almost unimaginable. And certainly that's how it was described when I started in the field as a researcher. But now we have treatments in clinical trial today that are being tested and being evaluated. The important aspect that I think we need to take away from the conference is beyond the fact that we have treatments and imagining how to use them, it also highlights the importance of being able to have treatments that stop the damage from happening. Because in order to repair a damaged nerve cell, one must have nerve cells still there for myelin to be repair to happen. And so it emphasizes the need to have both treatments that stop the disease, identify early intervention, but also some of the other advances around protecting the brain when it is experiencing the damage associated with MS. And that's, that creates a supportive environment in which myelin repair can happen. And at the conference, we've had a number of conversations about early stages, early molecules that are being tested and evaluated, and it has great possibility for people today. We have had some trials that have not been successful, but we've also learned when to use the treatment, when to begin evaluating it, and then most importantly, how to use it in combination with other treatments.
Bruno, I know this is a topic that you're keen to discuss.
Yes, it may appear as a, let's say, complex field, and it has been a matter of decades of research, which has been mostly a biological research. But we learned a lot about the mechanisms that may underlie how the brain can repair itself. And we are now more clear about this. And what has been shown here is some advances about who are the actors, the cells that will play a key role in the repair process, and that we may target with drugs in trials. Because at the beginning, we were thinking that remyelination, it's only the matter of the remyelinating cell, but it's also the matter of the environment. And Tim mentioned very well that you need a healthy neuron to be repaired, but you need also a welcoming environment, as usual. And so this welcoming environment depends on other cells such as astrocytes, macrophages, and so on. It's a little bit technical, but what has been presented during the remyelination session here was very accurate mechanisms that could be targeted for future trials. The second casing is how we are going to conduct this trial. It's not a so simple question. It's not the same than preventing relapse. And so we have now made progresses in terms of the outcomes that we can use that may capture the neuroprotective effect of a drug or the remyelinating effect of a drug. I will mention a very interesting work performed by a young student that developed an artificial intelligence tool that is applying now to everybody, maybe in real life, to capture the remyelination process. And by having enhanced such tool, we'll advance and accelerate the development of this research for remyelination. And so now the point where we are is also that we have many potential drugs that could be applied further in originally designed trials. And some are already ongoing. We heard a few years ago that clemastine, for instance, were able to promote a little bit remyelination in CNS. And then there have been a second drug, bexarotene, and there are now plenty of potential drugs that could be applied. And we have to think about how they could be applied. So it will be the time of enrollment of subjects in those, at this stage, still small trials. It's not the huge trials that you can see in phase 3, but they are very promising. And we hope that this may accelerate the application of those drugs and those concepts to the real life.
Fantastic. And so I've had a question submitted online that I want to throw to the panel for a quick answer, because it's going to be not an easy question, but I think one that is important that we discuss, because with all of these, we really want to put this into a context of what does it mean for you, the audience. So to summarize what we're saying, we've made a lot of advancements in terms of our understanding of what controls these repair processes. We're going through the process of now starting clinical trials in this area. So the question that we've received from a number of people is, what do we think is the time frame, the realistic time frame before we might see an effective remyelination therapy approved? A very difficult question to start with, that no one is going to want to answer.
It's a horrible question. It's not, because we cannot engage on this field. It's very difficult. It depends on how powerful will be the first or the first set of drug we will test. We are talking about years, not about decades. This is what we can say. We are trying to do our best to accelerate. And we are doing international effort to accelerate. For instance, ECTRIMS, together with partners such as NMSS and so on, we have organized meetings this year to discuss about how we can accelerate this research, how we can conduct trials. And so this kind of international collaborative effort is the best that we can do, to push forward those trials and to say we can probably advance this field in years, probably not in decades.
I'd like to add that in research there is always also the fact that the most difficult things are always the first ones, no? And we have seen this with immunomodulation, no? When I started working with this disease, there were no treatments, and it was like impossible to think about treatments. Once we understood that there was an inflammatory process and that we started with the first, let's say, anti-inflammatory drugs, then it was like a cascade, no? And I think this is where we are with the remyelination process. We are at the first steps, and hopefully we will see also this cascade of new things coming once we have understood better what is happening, because this is a very translational disease. And if we don't understand what is happening, it is very difficult to try to reverse the process. So it's been a long time because it's a difficult process. And the good things is that we understand now better what is happening. And I'm convinced this is going to have like this spread of more concrete things.
Tim, did you want to finish off on this?
So to build on what Mara and Bruno have outlined, I think the aspects one can also keep in mind is that what's happening today, convening activities like ECTRIMS has created, are actually accelerating the process. So clinical trials are typically 1, 2, 3 years in length, and that is how a typical trial will take place. But the opportunity of collaboration, sharing of information about what has worked, what hasn't worked, happens so much more quickly today as a result of the scientists gathering together and knowledge about outcome measures that work or don't work. Instead of taking years, sometimes decades, to be incorporated into trials, are now more months and maybe a year or so. And so that collaboration is something to be hopeful for. It is hard to accelerate the scientific process, but one of the things we can do as organizations is accelerate collaboration and imagination, and that's what we saw at this conference. And what gives me hope that myelin repair now is, as Bruno said, not in terms of decades, but in terms of years, and maybe hopefully soon really accelerating that first phase 3 clinical trial that will be presented at the late-breaking session of a future ECTRIMS.
Well, okay, after hearing that, we're not maybe quite as excited. They're talking years, not decades, but they're really wanting to be sure we don't get our hopes unrealistically high that anything's going to happen anytime real soon. And I appreciate that. I do. But it's not as if we're relying only on the research that was presented at ECTRIMS as a possibility for remyelination therapy. There's still stuff coming out even as we speak. There are clinical trials in the works. There are other projects that are just gearing up and getting started. I wanted to give you a flavor of that, just so that you know this is not the end. There's still lots more coming down the pike for the reasons that I've already described. So the first thing is this article that just came out on another possible approach for remyelinating our nerves. The article's in Multiple Sclerosis News today, and it came out on September 12th of 2024. New collaboration will evaluate segestrone acetate as MS therapy. Progesterone hormone compound expected to promote myelin restoration. So we're talking about male-female hormones, and the progesterone is, of course, the hormone that's more associated, I think, with women, which immediately brought to mind the question, I thought more women got MS than men, so why would progesterone help with MS? So a question that perhaps this article is going to answer. Let's find out. The article says the pharmaceutical company Medunic Canada and Population Council, a non-profit research organization, are teaming up to investigate the potential use of segestrone acetate, a derivative of the hormone progesterone, as a multiple sclerosis therapy. The compound is expected to promote the restoration of myelin, the substance that surrounds and protects nerve cells and which is lost in MS. The multi-year collaboration will begin immediately, according to the new partners, with results from the first preclinical study expected by late 2025 or early 2026. So bear in mind, this is very early on. It's preclinical, so we're not even doing lab work. There's no clinical trials yet. We're just doing very basic, fundamental research to even see if this is an idea that should be pursued. And they say, should the findings be positive, Medunic Canada and the Population Council expect to launch clinical trials in patients soon thereafter, the two said in a joint press release. The Population Council is excited to enter this original research collaboration with Medunic Canada to investigate a potential new treatment for MS, a serious and unpredictable disease that affects 2.8 million people in the U.S., Canada, and around the world, said James Saylor, Executive Director of the Center for Biomedical Research at the Population Council. Some funding for the project was granted by the National Multiple Sclerosis Society, a U.S.-based nonprofit. And that's interesting because what it's saying is that a nonprofit is giving money to help fund the research. It's too early for the pharmaceutical companies to get excited enough to invest a lot of money in it. And they say Medunic Canada Population Council team up on possible MS therapy. MS is marked by progressive demyelination or myelin loss due to the immune system's mistaken attacks against myelin components. Consequently, nerve cells become progressively damaged and die off. The body is normally able to restore myelin that's been lost or damaged, a process called remyelination, but that ability is impaired in people with MS. Thus, therapeutic strategies to boost remyelination are of significant interest for treating the neurodegenerative disease, with numerous candidates in preclinical and clinical development. And we've been covering a bunch of those in my other videos. I'll put links to some of those in the description. Developed by the Population Council in the early 2000s, segestrone acetate is a potent progestin, a lab-made version of the female sex hormone progesterone. It's included as a component of certain forms of hormonal contraceptives that are sold in the U.S. Research over the last few decades has indicated that progesterone is neuroprotective and plays a role in myelin repair. See, those are kind of two different things. And I looked a little bit at some former studies and articles that talked about the neuroprotective effects of this compound. And so this myelin repair concept, I think, is a newer idea. But the outgrowth is from the original research that was on the neuroprotective role that it can play. And they say additional studies suggested that segestrone acetate may have similar benefit with the ability to promote remyelination and also reduce neuroinflammation in mouse models of MS. Oh, those mice, once again, giving their lives to benefit us. Thank you, mice. Its developers thus believe it could be a promising option as an MS therapy when combined with existing disease-modifying treatments. Segesterone acetate's potential ability to protect and regenerate neurons via neurogenesis, remyelination, and anti-inflammation indicate its potential clinical utility, said Regine Citruk-Ware, MD, a distinguished scientist from the Population Council. It is time to confirm the preclinical findings in a first clinical trial in patients with MS, Citruk-Ware added. At first, however, the new collaboration will focus on gathering additional preclinical evidence of segesterone acetate's potential as an MS therapy. The Population Council and Medigenic Canada will jointly oversee the research and provide scientific guidance through a scientific advisory committee. The initial planned study will be conducted by top-class experts in neurological diseases and MS management, according to the partners. Hopefully, we're going to find out more about who those folks might be. We look forward to conducting the necessary preclinical work and, if successful, proceeding to a proof-of-concept clinical trial in humans, said Rafik Marouf, Director of Medical Affairs at Medigenic Canada. Funding for the project comes from Medigenic Canada, a part of the Duquesne Pharmaceutical Group, along with a grant from the National Multiple Sclerosis Society through its Fast Forward program. Fast Forward supports the development of new MS treatments still in the preclinical stages. And so that reiterates what we talked about before, that it's a little too soon for the pharmaceutical companies to start throwing money in this direction, but they think it's promising enough if the National MS Society has given some funding for this. They must think there's some promise there because they don't fund every idea that comes along. So I guess what we will say is watch this space because you just never know. One of these things is bound to be the breakthrough that we're all waiting for. It may be this one and it may not, but let's keep an eye on it just in case. Well, there you go. That's an interesting one. I keep thinking, all right, why is it then that possibly a female sex hormone might play a role in remyelination when women get MS 2-to-1 over men? But then again, the body's a complex thing. Who knows? As the old Rongo commercials used to say, but that's not all. Let's take a look out at clinical trials. Again, it's just going to be a menu approach. I'm just going to show you what's out there in the offing so you can get a sense of the range of studies and locations for those studies. And hopefully that will encourage you that this is a topic that is not going to go away anytime soon. So let's just take a look at what's out on the clinicaltrials.gov website right now. I searched, as you can see down here at the bottom, multiple sclerosis and remyelination. And let's see what I found. Now, I won't be clicking on any of these in the interest of time. And likewise, we're only going to look at the studies that are actually recruiting right now, not the ones that have been terminated or completed or withdrawn or status unknown or any of that. Out of the 30 results, about half of them fell into that other category, and feel free to go look, please. But we won't look at those here today. But I will link below this page so that if you want to go out and look at any of these, feel free because there's quite a few of them, as you can see. This first one is actively recruiting. It's called Exploring Cortical Remyelination in Children with Multiple Sclerosis, and it's coming out of France. Then there's one here that's active, but it's not recruiting, so they must have gotten their full complement of people. And it's called Effects of Oral Cladribine on Remyelination and Inflammation in Multiple Sclerosis Patients, out of Porto Alegre, Brazil. And here's another one that's recruiting out of Italy, Demyelination and Remyelination in Multiple Sclerosis detected by brain, amyloid, PET, and CT scans. And here's another one that's active but not recruiting, aerobic exercise for remyelination and multiple sclerosis out of Portland, Oregon. This is the one that I just finished. And here's one that's recruiting, metformin add-on clinical study in multiple sclerosis to evaluate brain remyelination and neurodegeneration. And this one looks like it's out of Belgium. Here's another one that's recruiting out of Paris, France, remyelination in multiple sclerosis, a PET-MR longitudinal study investigating individual profiles of myelin repair and the contribution of neuroinflammation. Here's a recruiting one, CCMR2, a phase 2A randomized double-blind placebo-controlled trial of the ability of the combination of metformin and clemastine to promote remyelination in people with multiple sclerosis, and that's coming out of the United Kingdom. Similar to something else we had heard about in one of our other videos, where they were looking at metformin and clemastine as possible enablers of remyelination. Here's one that's not yet recruiting, doesn't mean it ever will even, but right now, that's what we've got. It's coming out of France. And here's one that's recruiting. Vasodoxaphene acetate as a remyelinating agent in multiple sclerosis. Now see, that's yet another thing altogether. We hadn't heard anything much about this, but if you're interested, it's recruiting in San Francisco, California. And we have one that's actively recruiting out of Amsterdam in the Netherlands, clemastine fumarate as remyelinating treatment in internuclear ophthalmoparesis and multiple sclerosis. Sounds interesting. And then we have another one that's recruiting out of various places in France. Totem RRMS, testosterone treatment on neuroprotection and myelin repair in relapsing remitting multiple sclerosis. Well, that's a very interesting one because it ties right in with the one we were just looking at, progesterone, which is a female sex hormone, and testosterone is a male sex hormone. So very interesting. I think they're kind of paired, really, these two studies. It would be interesting to know more about this one. And a study that's actively recruiting in Basel, Switzerland, imaging the interplay between axonal damage and repair in multiple sclerosis. So you get the idea, don't you, that a lot is going on with remyelination research. So what you've heard about at ECTRIMS is not the end of the story by any means. They're going to keep after this until something finally shakes loose and they can bring it to market and use it in the clinic. And I'm looking forward to that day, I have to tell you. Well, that was an awful lot, I know. But I hope that after watching this, you feel like you understand a little bit more about the breadth and the depth of the research that's going on around remyelination. It's not just a pipe dream anymore. It looks like something that is going to happen. It's just a matter of time. I don't know which therapy is going to prove to be the best either. It might be one that's just now in the pipeline. It might not be any of the ones that was presented at ECTRIMS. We just don't know. That's how breakthroughs happen. They are not predictable. They're probably the one that nobody would have put any money on at first, right? That's kind of how life is. But be that as it may, leave me a comment if any of those clinical trials looks interesting to you, if you're going to follow up with the contacts, maybe get involved. If you want to know more about any of that research, let me know. I will dig into it for you. And we can do yet another video on remyelination because that does seem to be one of the hotter topics right now. But that's all I have, so until my next video, please do take really good care of yourself. You see the reason why I want you to do that, because good things are coming, and they may not be that far away. I'll see you again soon.